Hey everyone, continuing our graphs and transformation, we'll look at this example right here. It's a specific type of question that will appear in the H2 math syllabus. So we have this rational function, our polynomial rational function, where we need to find a set of values y can take without using a calculator. So how are we going to do that, right? What do you mean by find a set of values y can take? In other words, you're essentially trying to find the set of values of y that has a corresponding x solution, which means that for y to be valid, it must have an x solution, a corresponding x solution. So what we're going to do first is, let's try to form a sort of a relationship. So I'm going to multiply by x plus 1 on both sides to give me yx plus 1 plus, it equals to x squared plus x plus 1. Bring everything to the same side, so I get x squared plus x, 1 minus y plus 1 minus y equals to 0. And you get sort of a quadratic equation. Of course, now with x and y inside, with y being the coefficients. So what do we do from here? So we use the same idea that, like in our discriminant, we want to find the specific values of x that will make the equation, or well, find the value of x such that we can get equation equals to 0, right? The quadratic equals to 0. Same thing for here actually, where we have x and y both making the equation 0 as well. So we're going to use the discriminant again. And because x is our input, we're going to do the discriminant with respect to x. So in order for y to be valid, x must be valid. So in order for x to be valid, it means that x must have a solution. So I'm going to write that relationship for you. So y is valid, which means that x is valid. So if x is valid, there are x solutions for our y. Right? So that means if there are x solutions, it will simply mean that b squared minus 4ac is bigger than or equals to 0. Alright? Then from here, we just simply put our b, a, and c. 1 minus y whole thing square minus 4, 1 minus y. Right, bigger than equals to 0. Factorize out 1 minus y. I get 1 minus y minus 4, so I get minus 3 minus y bigger than or equals to 0. I then have, well, it's going to be fun. So y minus 1, y plus 3 bigger than equals to 0. Alright, so I basically factorize out minus 3 minus y to be minus bracket y plus 3. I put a minus sign inside here to give me y minus 1. Alright, so from here we know that the set of values that y can take, well, from here you can easily tell is y bigger than equals to 1 and y less than or equals to minus 3. Since they want the set of values, our solution is then simply, well, we have y being a real number. Can put a dash line here, then y bigger than equals to 1, or actually you can use the word union, or this is word, or y less than equals to minus 3. Alright, so I repeat, basically this is your entire logic here, where you're looking at the idea that for y to be valid, you must have a corresponding x value. So x is valid, and that means x is a solution for x. Alright, therefore discriminant is bigger than or equals to 0.